Hey, how's it going? RouterOS version 6. It's quite old now, but people will still be using it. People have legacy devices out there which can't go any higher or run the new version 7 particularly well. So I thought it's worth doing this video just to go through the basic setup. So we're going to use our home HAP AC Lite. So we're working with AC Wi-Fi, but the Wave 1 version. We'll be using the older version of wireless configuration, but a lot of the steps will still be similar, or as they are now on the newer version. So this is the, as I mentioned, the device we're looking at. Still a decent enough unit if it's for your home or for a small office. You could even use it if you've got a mobile caravan or motorhome or something. It's got 2.4 and 5 gig. It's AC, it's still Wave 1, but it's still pretty it's better than the N, for example. And you can pick these up for sort of $100. Not very much money. And then I've just basically downgraded mine to the long-term support, which is also the same as the stable now, because there's going to be no more releases of version 6. So although my device can actually go higher, this is basically to simulate if you had an older model which couldn't go any higher. So let's get going. So open a WinBox. Now this is structured around sort of an entry-level beginner's guide. I'm going to go for a full config for LAN, the WAN, DHCP server, DNS, the firewall, the NAT, and then the Wi-Fi. So so we'll start off with I've reset it to factory. I normally reset them and I do no default config, but I'll just sort of simulate as if this is fresh out of the box, or you've used the reset process of you holding in that reset pin, plugging the power in, waiting for the lights to flash, and then removing the pin. That's how you do a reset. And we'll just jump in using the MAC address. So with the WinBox, if you're not familiar, this neighbors tab here will tell you everything. It will discover everything on your network from a layer 2 perspective. I'm directly connected into my MikroTik here, but I've also got a second NIC on my machine so I can remotely get to it and demonstrate basically, and won't lose access. Because at the moment, although technically on the default config it's giving me internet access because I'm using the same ports it would use, I'll go through why we're going to remove that config. So out of the box, plug it in, connect to its MAC address. I always prefer to connect to its MAC address. Default is admin no password on the older models. If you do have a newer model, it's worth noting that the password is actually now going to be set in that config, and it will be written on the bottom of the device next to the serial number, as well as the default SSID. So so if it does tell you incorrect password and you've reset it, then that'll be why. So out of the box we have this default configuration menu that appears, and this will basically tell you all the configuration that's on the box. I err on the side of wanting to know what's configured on my device, which is why I'm going to remove this configuration, because although it's a fairly standard, it gives you the Ethernet 1 is going to be your WAN Ethernet. It creates you the bridge. Basically, we're going to replicate a lot of the stuff that's already on here, but by us doing it, we're going to know exactly what we've configured. So we're not going to rogue DHCP, or we're going to know our firewall rules are set correctly on the right interfaces. So go ahead and remove that configuration. Now that may kick us off, but we can always just preempt that by killing that and then opening it up again. Now you'll see, if you noticed before, they had a default IP address in there, which is its LAN, which is the 192.168.88.1. Now that's disappeared because we removed that config. So again, we can jump back on using the MAC address. Okay. And now it will ask you to reset to set the new password. It's always good practice to do that now. because we don't want to leave it with no password. So the old password is just blank. And we'll just set password on there now, change now. There we go. Now what I always do at this point is I'm going to close this and then log back in. I'll show you why, because if we open up a terminal, every time we open up a new terminal, it's always going to ask us to log in, because we've just changed that password while we're in that session. So just close it, log back in again with your new password, and now every time we open up terminal, first time it's going to ask you about the license, but then on we're just straight in there. Okay, it's a little tip. Okay, so let's start with our LAN. So LAN, we're going to create a bridge. Now what a bridge does is, because this is a routed device, we're going to basically bridge those interfaces together into one network. So almost like, it's not the same as, but it's similar to like having a VLAN where you assign your ports to that VLAN. So we go ahead and just add our new bridge. We'll just call it something simple like LAN bridge. We okay. Then we add our ports into that bridge, and we've got 5 ports on here. We've got the interfaces. I'll show you the 5 ports, Ether 1 to Ether 5. One we're going to use as our WAN, which is plugged in currently, and that's just plugged into my dev network. That's what's going to be our internet access. And then the machine I'm on right now is plugged into Ether 2. So what we're just going to do is add 2 to 5 in our LAN bridge, because it's our new bridge. It's the only option it's going to give us. So it's pretty simple just to go through and make sure you do all those ports. 5. There we go. So now we have ports 2 to 5 are going to be on our LAN, because they're inside that bridge. We simply go to add an IP address. We go to IP addresses, and then we're going to add 192.168.0.1/24 as our LAN interface, which is then going to become our our default gateway for our network. And we just need to select that LAN bridge and interface. Don't worry about filling out the network portion. That will, when we click apply, that will propagate that for us there. Okay, so that's our LAN setup. Now let's set our WAN up. IP addresses again. So we could statically add an IP address in here for our WAN, but like most ISPs that do that, will probably give you that dynamically. So we're going to go to IPD DHCP client, and we're going to stick a client on our Ether 1. We're going to use peer DNS and NDP, and we're going to get a default route from that, because that's where we're going to route traffic. Okay, there we go. Grab us our IP, and we've got IP routes, and it will give us our routing table. As you can see, it's got the dynamic default route of catch-all pointing to our network off Ether 1, and then these are connected routes, which are our LAN and our WAN uplink. That's how to get to that network there. Okay, so pretty simple. We've now got we'll now have network access on our MikroTik itself, but we're not going to have network access on our machine yet. As you can see that we still don't have an internet. So what we firstly need to do is give our machine an IP address, and we want to do that dynamically like most home routers. So again, IP, this time DHCP server, not client. Now this is where we would configure all our network and our DHCP server here, and then we'd also have to configure our pool in here, which is our DHCP scope. So our range of IP addresses we're going to give out. But we use this DHCP option, this setup option, because it's just so much easier. It does everything for you without adding anything you don't want. So do the first steps first, create your bridge, give it an IP address, make sure that IP address is the range that you want to give out, and then you can select LAN bridge, and what it's going to do is going to pull that information for you. So you can see it's got our network there. It's going to give itself out as a DHCP server as the gateway, which is fairly normal. This is going to be our scope. So these are the range of IP addresses we want to give out. It's basically going to give out everything other than itself. But let's change this to let's close that range down a bit. So we want to add any statically set devices outside of that range. the DNS servers, what we're going to use, we're going to use ourselves. We're going to use our MikroTik as our DNS server, and I'll go through that in a sec. Least time default is 10 minutes, but I would always recommend you go to probably 8 hours, anywhere between 8 and 10, or even 12. It just makes the user experience a bit better. If this was an office, most people would be in your office for about 10 minutes, but anywhere between 8 hours and maybe 10 hours. So you don't want them to be renewing their lease every 10 minutes. Okay, and then as you can see, that's populated that network space there, and it will have created our pool scope there. Cool. So now we have DHCP server set up. Let's see if our machine has a. Click on that. There we go. Has an IP address. Yep, there we go. So we've been given out 100. And we can confirm that by going to our DHCP server and then looking at leases. There we go, there's my machine. And that's expired after that time. But we've still got no internet access. Oh, it says we have. Interesting. I bet that's because my upstream router knows about this network. Yeah, I'm thinking myself. Okay, no, I don't have internet access. That's just a bit of a false hope. Thank you, Windows. So we don't have internet access. Good. That's what we want. That's what we expect. So now we're going to sort out our NATing. So for those who are not familiar, basically your NAT is it's network address translation. So because of the finite amount of IPv4 addresses, there aren't enough, obviously, to give every device in the world an IP address. So ISPs will often give you a public IP address to use, which is in a range that they own or manage, and then that in turn, all your devices behind your network will be using the private IP range. But for that to route across the internet, what happens is your traffic will route to your default gateway, which is your network, and then it will route to its default gateway, which is your upstream, possibly your ISP. But then what it does is it takes your address from your device. So, for example, this machine I'm on now just got the IP.100. It's going to then change its source address to be the IP of the WAN of your machine, of your router, and then it's going to send that off into the internet, and it's going to be able to route to where you need to go, and it's going to find its way back to your router because your ISP is telling the rest of the world where that IP is. And then when it hits your router, it's going to then get translated back into your local IP address and then get forwarded onto your relevant device. And that's basically how the NAT works. It will maintain a sessions table for all the different connections out, and as they come back in, it knows where to route them back. So the term in MikroTik is called Masquerade, because what you're doing is you're masquerading, you're hiding behind that public IP address. So if we go, we're going to do it, chain is source NAT, you leave that as default. We're going to pick the interface that we're going to go out of, which is going to be Ether1, which is our WAN. And then you're simply going to just click Masquerade. So what that means is anything coming from your LAN effectively, and it is going to be going out, that's going out of Ether1, because that's what the routing table is telling it to do. It's going to take the IP address that's assigned to Ether1, which we can see IP address is here, and then it's going to masquerade, hide behind, or change to that IP there. Now, although technically that's a local IP address as well, that's only because I'm routing onto my development network, but that could, for all of purposes, be my ISP network or my public IP address I'm getting. Okay, so hopefully that's clear. All you need to know really is you just need to set you need at least one masquerade rule pointing at the interface that is your internet facing interface. Okay, now we should, in theory, There we go. Now we can ping the internet, but we won't be able to ping DNS entries because it's not going to be able to resolve that yet. Because if you remember, we set our DNS server. If I do ipconfig all, you can see on this network, sorry, my DNS server is the MikroTik itself. So the MikroTik will be able to, if I can type, so that can resolve DNS. As you can see, I've pinged that DNS name and it's telling me that's the IP address there, but I can't, because what I'm doing is I'm making requests to the MikroTik. The MikroTik's DNS server, go IPDNS, it's got it dynamically, so it's the upstream router, and also it's got this Cloudflare one. So it can make DNS requests because it has valid DNS servers, but the DNS server that I'm using is actually the MikroTik. So what we need to do is just need to tick this allow remote requests. And then now what that's going to do is tell the MikroTik that if you do get a DNS request coming, basically, yeah, if you don't have that in your DNS table, do a request yourself and find the answer. So I'm gonna try and access google.com. My machine is going to say to its DNS server, can I have the IP address for google.com? My DNS server, being the MikroTik, is then going to say, I don't have that, but what I'm going to do is ask my DNS server. And then eventually it works that way, and then it will pass it back, all the way back. And then this means then it's also going to make, it's going to cache a lot of the results. So if next time I ask for google.com and I don't have it cached in my machine, the MikroTik can then turn around and go, oh, I already have that cached, here you go. And it also then means that we can then add some static entries of our own. So if we wanted to run our own internal local DNS, we can then run in here. So if you've got lots of servers and stuff, media servers, and you want to give them host names instead of going to their IPs every time, you can then create entries in here, and it will overwrite anything that you try and make requests for onto the internet. So that's just a handy little feature. So now if we do that again, there you go, all good. So we've got our LAN, we've got our WAN, we've got our DHCP server, our DNS sorted. We can now route and connect to the internet. The only next thing we need to do is firewall. So the firewall is very important. So the firewall by default is empty because we've removed that default configuration. This means that if we plugged into a public IP address and then someone tries to access that public IP address, they could discover that you're on a MikroTik device, so they'll know to use the port for WinBox maybe, and then they just will try and hammer that until they get an entry. As I mentioned, this earlier version, version 6, the password is blank in the default configuration. So if you haven't set that, they're just the first thing they're going to try is admin and nothing, and they're going to get in. So yeah, it's very important that you follow these steps. Now I've done a whole video about the importance of these rules. So yeah, we're going to keep it really simple, and this is the basic you need, or the base limit you need, because at the end of the day, a MikroTik is a router. Its job is to route traffic. That's what its purpose is. It's not a firewall. So if you get a firewall like a Palo Alto or a FortiGate or something like that, they will have an explicit deny rule by default, because their job is to block everything, and then you tell it what you want to do. So we're effectively going to do the same thing. We're going to create that explicit deny rule, and then we're going to poke holes in our firewall for certain things we want. So the first thing to do, and it's very important that you always plan this out or make sure that you're not going to basically lock yourself out. So create all your allow rules first, and then create your deny rule. But also, we're going to be only denying it from a specific interface. We're just going to block everything from our internet-facing network. So like we did for that NAT rule, we did out interface has been Ether1. This time it's going to be in interface. So anything coming in from Ether1, we're going to deny. But before that, if we have anything, say we have a remote server somewhere, we have a remote VPN connection or an office, a network somewhere that we want to then access our home or this could be an office network and you want to access this from home, you can then, instead of having to create the allow rules per IP address you want it to come from, we're going to use this address list. So in here we can create a new one. We'll just call it allowed hosts. We'll just use a fictitious one for now because I don't have anything to access from. Okay, and now if we wanted to add another one, we can just pick that one again, put it in there. Now what this means is once we've created that, our rule is our first rule we're creating is our allow rule. So this doesn't really matter to us because I said we're only blocking Ether 1 and we're accessing it on Ether 2. But we could block this. We could have rules that will only allow particular IPs to access it on a LAN as well if you really want to lock it down. So just be mindful of that. But yeah, Ether 1, we're going to select the input chain because this is traffic destined for the router itself. So you've got input, anything coming into the router, output, anything coming out of the router that's generated from the router, and then forward is stuff passing through. So PC sends traffic to the internet, it goes through the router, and that is your forward chain. And that is what you would use for if you've got two LANs, like your home network, and you wanted to create like an IoT network for all your smart stuff, but you don't want that talking, you just want to give it some internet access. You would then simply block those two networks in the forward chain. But we're talking about input because we're talking about stuff coming out from the big wide world. So chain input, in interface Ether 1, source address is where we would put that individual address if we wanted. Those of you that have used version 7, this is now actually in the same on this first tab, but in this version we're using, it's actually still on the advanced tab, and this is the source address list. And then from there we'll have our allowed hosts, and that's whatever we create in here will become available in this drop down. Okay, so just go over that again. Anything coming in on the input chain from Ether 1 that is from those IPs in that list is going to be accepted. Okay, so there's our first one. Now we can add that deny rule below it. So then we go again, input, in interface Ether 1, and then this time we're not going to give it any other, we're not blocking from certain IPs, we're just blocking from everything else. It's going to be drop. So, and basically these work top down, so if it gets a match on a rule, it will apply that from that rule, and then it will stop. It won't carry on down the rule set. So the very last will be this drop. If you are building your firewall up and you want to be 100% sure, just disable it and then apply it, and then that'll basically mean that it won't be active until you actually enable it. But we can go ahead and allow that. So as you can see, that's come down. The numbers down the side is the order that they're in. If we were to then accidentally click that, it looks like the drop has come above it, but actually if you look at these numbers, 2 is below 1, so that should that would still take effect after this one. So we then just sort by number again. Okay, just sometimes you can accidentally click on that and think, oh my god, my drop rules above all my allow rules, and why is my network not broken? We just simply do that. Okay, now one thing, by doing this, what we've done is actually we've broken some stuff. So, and I'll go through what we've broken. So as I mentioned before, we're using the router to request our DNS. Now, DNS is going to be generated from our MikroTik. So it's going out on the output chain, so that's fine. But the request is going out, but what's coming back in is going to be coming into the input chain. Now what we've just done is we've just denied everything. Unless because in this example I've used Google's DNS server. If we were using that as our DNS, then yeah, it would be fine. But chances are you're not going to be allowing Google DNS into your firewall rules. So yeah, we would basically kill so if I ping something different, basically killed our DNS. Now what we do whenever we're troubleshooting stuff like this and we think it's a particular rule, we just click this log button and then we'll just type something like drop and apply. And what that's going to do is every time it gets a hit in there, as you can see it's got these hits here coming through, it's going to then log it under here. As you can see, there's quite a few things happening on my machine that's trying to get to the internet. Let's just kill that, and then we'll trawl through those logs and find the one we want. So what we're going to look for is those DNS. There we go, there's one straight away. So I've made a request somewhere along the line to my DNS server, which happens to be my default gateway on the router, which is the upstream network, my development network. It's now trying to send that request back to me, to my router, which is on 121, and it's dropping it. So if that makes sense, it's UDP, it's DNS traffic because it's 53. So what that means is I've made a request to the router's then not got it in its cache table. It's now making that request to its DNS server. It's made that request, but the request coming back has been dropped. So we could add some allow rules, which would allow, say, DNS port 53, but then do we want to allow every single DNS request to come back in, because people could, use that to their advantage to try and hack our system. So we could then also allow our whatever our DNS server is, like I've added Google here. But again, do we really want to do that? What happens if we change our DNS server, or we're getting it dynamically from our ISP and they change it? We don't want to be adjusting our rules all the time. So the trick is just in this drop rule, what we want to do is we want to allow the traffic type. Now, something of point, in newer RouterOS, in here it actually tells you the connection type, so you can identify it a lot easier. If I click on, does it tell me anymore? No. So basically what it is, the connection type is, if I click on here, the state, we've got these different states of traffic. So it could be a new request, a new connection, or it could be established. Established means the router has sent out the request, so it knows that it should be expecting to come back. It's marked it as established. So if it's established, what we want to say is, yes, you can come back in. So if we click this established, we're basically then going to be applying our action based on it being an established. But because this is our drop rule, we're still going to be dropping it. We're going to be then only dropping established traffic. We could then have a rule that is like this, where it's going to match anything coming in Ether1 and established and then accept. Or to keep it nice and neat and all in the same rule, we just tick this exclamation mark here button, and that basically negates it. So bear with me, anything coming in from Ether1 that is not established, we're going to drop it. So it's going to drop everything except for established traffic. So when we apply that, and then we try and do that same thing again, there we go, DNS, that works. And there's other stuff that would then break, so things like NTP, that would be then trying to get this time, would be sending out that request from the router, and it would then not be coming back in. So yeah, and all sorts of other HTTPS traffic and things, you just find it, stuff just wouldn't work because of that. So yeah, and basically now we've got our fully secured rule set in just 2 rules. So yeah, I like to keep things as small and as tight and neat as possible. If I can use lists, if I can group stuff together, yeah, that's my main preference. Okay, so there we are. So we've pretty much done everything now. We've got our router up and running. The last thing to touch on is the Wi-Fi. Now, Wi-Fi has changed a lot in the newer versions, with the dawn of AC Wave 2 and AX. So it's gone from what is called wireless here, and then it changed to, I believe, Wi-Fi. It was called Wi-Fi Wave 2, and then it's gone to just Wi-Fi. The Capsman, if you're familiar with Capsman, is basically like the controller-based system for if you've got lots of access points. That is now integrated into the Wi-Fi system, whereas here you can see it's a completely separate menu. And in the kind of, if I was to upgrade this to the latest version, 7 something, it would actually give me 2 menus. It would give me the new Wi-Fi one, which when I click on it would have no interfaces, and then it would give me a sub menu which would have the Capsman and the wireless in it. So we want this wireless one because it's the only option here. And the other thing of note is in the newer version, the 5 gig interface is actually WAN. It's called now wireless 1, and wireless 2 is the 2.4, where it's reversed here because the primary one was 2.4 initially, because that was the only one that was available, and then since the advent of 5 gig, then that's become the second interface, whereas now 5 gig is the primary one that's pretty much used as standard by most devices. Okay, so all that said, this is also a lot simpler to configure, I think, basically because everything's all in the one menu. We actually make the configurations on the interface itself, whereas the newer ones is very much like the Capsman. It looks very similar to this, where we have these all sub menus. So we create our configuration, we create our data plane, we sort our channels out, and then we apply it in this configuration, which we then apply to our interface. So that's very much how the Wi-Fi wireless works. Whereas here it's very simple. We just got the two interfaces. They only show up if they're actually on the, if the device you've got actually has Wi-Fi in it. You had a non-Wi-Fi router, you'd still have this menu, just be nothing in here. Okay, so let's go through and configure them. Basically, as I mentioned, this is the WLAN 1 is 2.4. So what I'd like to do is just rename this to say Wi-Fi 2G for 2.4. So when I apply that, you'll see it changes its name there. So just easier to remember. 5G. Okay, so we start with 2.4 and we just work our way along here. Wireless mode is going to be AP bridge. There's lots of modes in here. Don't worry about these. A lot of these are for point-to-point links and things like that. But we are going to act as an access point. Band, let's just use N only. Channel width, always to 20 megahertz on 2.4. Frequency is where we can then select either auto, and it's going to pick any frequencies, but best practice in 2.4 is to use channels 1, 6, and 11. So we've got channel 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that one. And then it's also got 12, 13. So we want it to use, basically, we can then manually pick our interface there and there. Or if we click on the advanced mode, what we do, we're going to put these frequencies as individual ones in this what's called a scan list. So we could do a range, but we wanted to keep it between these three. Okay, get rid of that one. So, scan list. First thing you do, click on advanced, gives you all these extra options. Scan list. Put your frequencies in here, and then set this to auto. Now what that's going to do is it's only going to use these ones when it picks its frequency. Okay, because we want it to be auto, we want it to give it some, it's going to detect what other frequencies around, it's going to pick the best one. 2.4 is a very small band and it's highly congested, so it doesn't have a lot of options there, but it will do its best. Okay, SSID. 2G, I always separate my 5 and 2.4 out because, wireless is pretty dumb when it comes to that sort of thing. It's up to the client to make the decision what band and when it roams. So yeah, I like to choose 5 gig for all my devices unless they're legacy and they use 2.4. So some of these we don't really worry about. We can specify as Wi-Fi only. This feature, skip the EFS channels. Yeah, that's gone in the newer ones, I think. But regulatory domain, it's probably good to set that. I'm in Australia, so installation indoors. So yeah, these are, you can get away without setting these. It's just force of habit. That's from when I used to have to configure lots of these. So that's pretty much that set. The only other thing to do is the one thing we do create out here is our security profile. So we create that while this is still open. We can use this default one. Select mode as dynamic keys, WPA2, PSK, and then we're going to give it a abbreviated key, which is basically your password. Can't see the password there when we type it, but if we go to settings and untick hide passwords, there we go. Hello world 123. Nice and secure. Okay, that. And now under security, it's already got default selected. If we added a new one in there, that would then appear in that drop down list. So that's that all set. We okay that. And it's still disabled by default. So we might as well enable that now. Okay. 5 gig one. Again, advanced mode. I've already renamed it. We want to change it to AP bridge. Band, let's go for NAC. Again, I'd always use 20 megahertz for 5 gig, even though it's a bigger band. We're not really looking to push a lot of bandwidth across Wi-Fi. I know you can in some of the newer ones, but you know, who does? It means using the whole of the frequency. So yeah, let's just be realistic and keep our channels nice and clean. Frequency, again, we've got that option here. We've got this is a bit more involved about the different types, different bands to use. Okay, in fact, which might show this a bit clearer is if we go to my website, MikroTikMarketing.com. I've got this article about 2.4 and 5 gig Wi-Fi, and then I just basically explain the spectrum. So we've got 2.4. These are 1, 6, and 11. As you can see, there's the frequencies that they represent there, and they're the usability. So these are the ones you use because they're non-overlapping. And then 5 gig, again, a lot more channels to choose from, but the ones all in the middle here, these DFS section, which basically is radar detection. So if it detects anything remotely radar-ish, it's going to not use them. Your Wi-Fi is going to basically be turning on and off the whole time. So we've got basically these 4 here to use and these are in the UNII version 1 end of the spectrum, and then the UNNI version 3 at the other end. There's another 5. So you can get away with using these ones as well. I would just steer clear from this middle band completely if I were you. So then again, you've got a big spectrum, but again, it's kind of limited, and also, which is the other reason I would only ever use the 20 megahertz channel, because if you used 40, or you've then limited to just using, you'd only getting 2 out of this end, and then if you were to use the full 80, you pretty much use your whole section here just on one SSID or one access point. So yeah, so we're going to allow it to pick out of all of these ones. So we can just put this side by side to our MikroTik, and we add these in. And then what I'm going to do is I'll do the first couple, and then I'll perhaps just fast forward so you don't have to watch me copy and paste into all of them. So before scan list, 5180, 5200. Okay, so as you can see, I've got all those in there. So the first 4 and then the second 5. So I've got 9 in total. We'll just select this to be auto, so it picks from one of those. Okay, MikroTik 5G. Yeah, again, we don't really need to set any of this necessarily, but Australia, not Austria. It's just kind of best practice. Okay, there we go. Security profile is the same as the one we use for our 2.4 gig. Okay, so we're going to okay that, and then enable that, and now we're going to have our 2 networks ready. Okay, make that big again. Okay, so now we've got Wi-Fi. The last thing we need to do is just add these interfaces now into our bridge, because they are going to be part of our LAN. So go back to bridge, add those in here. 2.4, 5. Okay, let me just grab my phone. We'll go to, I'll show you where you see the connections under the wireless table if you go to registration. Just bring up Wi-Fi. Okay, the 5G one there. Let's try that one. Hello world 123. Okay, connect. There we go. That was quick. Connected. I've got internet access, and if we go to IP DHCP server, there we go. We've got another lease in there, which is my phone there. Just the 2 gig one as well, just to make sure I haven't made any typos anywhere. Hello world 123. And then see the interface now has changed to 2 gig, and because I'm on a different interface, it's giving me another IP address. Okay, so that's that. So yeah, hopefully that's clear enough. We've got our LAN, our WAN, all the stuff that goes along with it, our DHCP server, our DNS, everything you'd find on a traditional router, and this would then be pretty much good to go for your home setup or your small office, or like I mentioned, if you've got a traveling or anything like that, you could then take this with you, connect it to whatever internet source you like, and you've got your same network set up. But yeah, if you've got any questions below, if any particular setup, if you're still using, so a lot of the videos I've been making recently, everything's on the latest version. By default, I'll just use whatever's available unless there's something specific I need to. There's a feature that's missing from the latest. But if you do have if you are, you've got a full network that's deployed and it's older stuff, and you don't want to be, or you're worried about going to version 7 because you're worried it won't run it well enough, and you've got a particular setup or issue or something you've tried, and you're aware of how it works in version 7, but you're not in version 6, then let me know and we can make a video for that. But if not, thanks for watching, and then I'll see you on the next one. Thanks.